Hey everybody, it's Mr. Mott. What we're going to do is go through how to read one of these solubility curves or solubility graphs. We can see the axes tell us a lot. On the x-axis, we have temperature. Solubility is very temperature dependent for most substances. We've got grams of our solute per 100 grams of water. So for a lot of these, we're just sort of finding a point on the axes. If we know the temperature, we want to figure out how many grams can dissolve for that particular substance. So let's say that we were looking at KNO3. We wanted to know how many grams of KNO3 could dissolve the maximum amount at 50 degrees. So we'd find 50 degrees on our x-axis. We'd go up, and then once we hit our line, which represents a saturated solution, the most that could dissolve, we would go over and see where it hits on the y-axis, and so we would be at 80 grams. Okay, if we were looking at a different substance, for instance, and we could kind of go the other way as well, we could say at what temperature would we need to dissolve 100 grams of KNO3. So then we would go, if we had 100 grams, we would look at the y-axis here. And again, if we were looking at KNO3, we'd see where that hits our line. And then we would go down. And so what we would have to have is 100 grams of water at 60 degrees to dissolve that 100 grams of our solute, KNO3 in this case. All right. Some of the other kind of questions you could be asked. You could be asked what type of solution would we have at a certain point. So let's say that we are dealing with NaNO3, and let's say that we had 90 grams dissolved at 40 degrees. So we'd kind of go across and say, okay, 90 grams hits 40 degrees here. So this is our data point. And so for NaNO3, that's below the line. So if it's below the line, we know it's unsaturated. So this one would be unsaturated. You could then be asked, well, how many more grams would we need to make a saturated solution? And so it'd be the difference from here to here. And so if we go across and we see where that hits, that's maybe roughly 105 grams. So if 105 grams is the maximum that can dissolve, and we already have 90 in there, then we would need to dissolve 15 more grams or add 15 more grams of the NaNO3 to make a saturated solution. All right. So that's another type of question you could be asked. Let's do something else that's a little bit more complex. Let's say, for instance, that we had, let's say that we had a saturated solution. Sorry about this mess. Let's say that we had a saturated solution of NaNO3, and let's say that was at, let's say that it was right here. And so let's say that that is, if we went down on the x-axis here, let's say that that was at 55 degrees. So let's say if we had a saturated NaNO3 solution at 55 degrees, and then we cooled it down to maybe around 10 degrees. So we would cool this down to around 10 degrees. We could say, well, what would happen? Well, at 55 grams, we can hold around 120, at 55 degrees, we can hold around 120 grams. So at this temperature, we can have 120 grams dissolve. And then at 10 degrees, so at 10 degrees, around 80 grams can dissolve. So if we went over here, about 80 grams could dissolve. So what would happen is that 40 grams of the NaNO3, it would come out of solution. And so we would use the term usually precipitate out of solution. If you remember from our pH lab, we used the term precipitate when two liquids came together and they made a solid. we use a similar kind of term because this is solid is coming out of the solution, so similar idea. We could have asked a similar question if we had started at 10 degrees of a saturated solution and we raised that temperature to 55, how many more grams would we need to dissolve? And again, it's just the difference. So we're kind of finding the difference between how many grams can dissolve at that point. So it's kind of like looking at here, if you will, looking at that difference, which is about 40 grams. All right. One of the trickiest questions you could be asked would be, what if you have a situation where you have a point sort of above the line, and what kind of solution would you have? So let's erase a little bit of this stuff and then see what we can come up with. All right, so let's say that we had a data point, let's say for NH4Cl, so this particular chemical. So the line that represents this is here, and our data point is above that. In other words, they said we have 100 grams. Let's say that we have 100 grams of water, and then we add 70 grams of NH4Cl, and we're going to say at, if we go down, this is going to be at 70 degrees. And they would ask, what type of solution would you have? Well, if you're above the line, your book would say that we have a supersaturated solution. Now, if it's supersaturated, then all that solid must be dissolved. If we had some crystals, so that's kind of scenario one, that could happen. If we had some crystals that were not dissolved, or some solid not dissolved, that would mean we'd have a saturated solution. So that's kind of how we would handle if we have a situation like this where, again, we have 100 grams of water, which is what our table is telling us. We're above the line. We would need to know more information about what everything looks like. All right. So hopefully that helps understand solubility curves. Thanks for watching.